Hi students, in this video we are going to see vector equation of a plane. Here we are going to derive the vector equation of a plane. It is similar to what we learned in the Cartesian form. Instead of instead of coordinates x comma y, here we will make it in terms of vectors. So consider a plane passing through a point A, x1, y1, z1 and with position vector of r0 vector. Considering this x coordinate, y coordinate, z coordinate, there is a point A whose coordinates are x, y, x1, y1, z1 through which this plane passes through, and based on this point and origin we are making the position vector of A, that is r0 vector. It is similar to what we learnt in Cartesian form. Also consider a vector n vector perpendicular to the plane. Since this vector is perpendicular to the plane, we can call this as normal vector. This is also again similar to the previous concept. Let A, B, C be the direction ratios of n vector. When direction ratios are given, we know how to write it in the vector form. That is, n vector is equal to A I cap plus B j cap plus C k cap. In Cartesian form of the plane also we have seen the similar concept. I already told you that A, B, C are always direction ratios of normal vector in this plane concept, right? And let P be any arbitrary point lying on the plane and R vector be the position vector of P. Again, this point also has come in the previous concept. Here we have one extra concept, that is R vector is the position vector of B. This means R vector is a vector whose direction ratios are x, y, z, because P is an arbitrary point. It can take any x coordinate value, y coordinate value, z coordinate value on the plane. Hence, it is normally denoted as coordinates of P are denoted as x, y, z. So, R vector can be represented as x I cap plus y j cap plus z k cap. We know that the point A and point B lies on the plane. Hence, AP vector is also perpendicular to n vector. And we know that two vectors are perpendicular means their dot product is 0. Hence, AP vector dot n vector equal to 0. AP vector can be represented as position vector of P minus position vector of A. Position vector of P is R vector and position vector of A is R0 vector. Hence, R vector minus R0 vector dot, in place of n vector we are substituting this A I cap plus B j cap plus C k cap. Now R vector dot A vector dot A I vector plus B j k vector plus C k vector minus R0 vector into this, right? And we can transfer this to the right hand side. We are keeping this R vector dot A I cap plus B j cap plus C k cap. R0 vector contains coordinates values because R0's coordinate are x1, y1, z1. x1 is a numerical value, y1 is a numerical value, z1 is a numerical value. Dot A I cap plus B j cap plus C k cap means we know direction ratios of this normal vector A, B, C are numbers. So direction ratios is multiplied with this x1, y1, z1 numerical value means we will get a number, that is a length. So we are denoting it as D. You know that this D must be non-negative integer. So R vector dot A I cap plus B j cap plus C k cap equal to D is the vector form of the equation of a plane, and this can also be written as R vector dot n vector equal to D because this vector is represented as n vector. So vector form of the equation can also be represented as R vector dot n vector equal to D. Here R vector means arbitrary vector, that is x I cap plus y j cap plus z k cap. Dot n vector is a normal vector which is equal to D. You already know how to calculate this D value. Hence, we can go to the conclusion. If A, B, C are the direction ratios of a vector normal to the plane, then the equation of the plane, that is the vector equation of the plane, can be written as r vector dot a I cap plus b j cap plus c k cap equal to d, or r vector dot n vector is equal to d. D is called as non-negative real, d is a non-negative real number, and this form of vector can also be called as scalar product form, because dot product always produces scalar product, scalar value, hence it can also be called as scalar product form. I hope you understand this concept very clearly. Now in the previous video we learnt Cartesian form. Cartesian form of a plane is ax plus by plus cz is equal to d. D is a non-negative number. Here vector form of the equation is r vector dot n vector equal to d. So these are the two easy formulae that we can remember it easily. And one more formula, one more equation we came across is general equation of the plane. General equation of the plane is ax plus by plus cz plus d. I hope you understand and you can remember all these different forms of equation of the plane. In the next video we will see normal form of the equation of a plane. Thank you students. Thanks for your cooperation.